Welcome to the tutorial. Know about electrical panel and maintenance. Electrical panel. Part 12. Power factor. Power factor is the ratio between active power and apparent power. In an electric power system, a load with a low power factor draws more current than a load with a high power factor. The higher currents increase the energy lost in the distribution system. Any event related to the electrical network which ultimately results in financial loss is called a power quality problem. What are reactive power kVAR and active power kW? To understand what is reactive power kVAR, you must also understand what is real or active power kW and apparent power kVA, because these three are interrelated. Although reactive power is the most important component of electricity, it is the most difficult part to understand. I use a very interesting analogy here to explain this. While this may not be 100% correct, these similarities will help you to easily understand what reactive power is. Coffee mug similarity. The coffee mug similarity only explains the extent of the relationships between real, apparent, and reactive power. The following is given in the image provided here. kW is the working power. This is the actual power that consumed the equipment and performs useful work. kVA stands for apparent power. This kVA is the vectorial sum of kVAR and kW. kVAR is the reactive power. This is the power that magnetic equipment required to generate magnetic flux. From the details what has been said here, we can clearly state the need to reduce kVAR. Through the picture of the coffee mug shows that the higher the foam reduces the coffee. From this it is understood that the higher the kVAR will reduce the value of kW. Let us look at a simple example to better understand these terms. Suppose a mug of favorite coffee is ordered for you. The main part of coffee represents kW and a little bit of foam that you get in the mug along with the coffee represents kVAR. Assuming that the total coffee in your mug is kVA, it is a sum of kW and kVAR, that means coffee and foam. From this, we can understand the relationship between kW, kVA, and kVAR. Therefore, we now need to understand a few basic details about the power factor. Power factor is the ratio of active power to the apparent power. Power factor equals kW divided by kVA. Looking at the coffee mug, we can say kVA is the sum of kW and kVAR, so that power factor equals kW divided by kVA. Or, power factor equals kW divided by kW plus kVAR. That is, power factor equals coffee divided by coffee plus foam. So say simply, having a low kVAR means that the system has more kW is available, just as a coffee mug has less coffee and more foam. We now know that kW, kVAR and kVA are vector quantities, so we can see another simple example to understand this in vector form. Man-cart analogy. As shown in the figure, when a person wants to pull a cart, the actual direction of movement that to use is kW. As he cannot pull the cart directly, he has to lift the link a little bit up to pull comfortably to the destination. Now this lift, which is necessary but not directly useful, is marked as kVAR. The total power is marked as kVA. So that, as per Pythagoras' theorem, power factor equals kW divided by kVA. Since kVA equals kW divided by square root of kW square plus kVAR square, so the power factor will be 1, which is when the system is running under optimum condition. So to make it unity, we cannot reduce the kVAR, because when we reduce the kVAR in the above picture, the person cannot pull the cart easily. So similarly in the power system, we cannot kill the reactive power, we can only compensate for it. To make the system perfect to do the effective work, we have to add a power factor correction unit attached to the main electrical panel. Power factor correction increases the power factor of a load, improving efficiency for the distribution system. End of part 12. Thank you for watching the tutorial. Subscribe to the channel to get updates and more videos.